So in this video we're going to be taking a look at this problem right here, and what this problem is asking is the limit as x approaches 12 from the left, and that's denoted by the minus sign right here, of the absolute value of 5x minus 60 over 12 minus x. So the main thing with this problem right here is the fact that there's the absolute value on the top of the fraction. And what we have to remember for the absolute value is that we can rewrite it as a piecewise function. So if we just have a standard x, and we have an x and it's in the absolute value, we can rewrite this as if x is greater than or equal to 0, and then also if x is less than 0. In this situation, if it's greater than 0 or equal to 0, it would just be the number itself. But if it's less than 0, it would be x with a negative out front. And then looking at this part right here, what we want to do is find out what the point of interest right here is, and to do that we would just set this equal to 0. Then we get x equals 12. And then what this means is that's where we're going to see the change in the graph at that point, at x equals 12. So if we're trying to find the piecewise for this part right here, we would have the absolute value of 5x minus 60. And then we can break this into two parts. So for one part, we would have x is greater than or equal to 12, and then the second one we would have x is greater than, or is less than, sorry. It's less than 12. And so for this case right here, we would have a positive number. So it would just be 5x minus 60, or we would have 0 in this case. And then for this one, we'd actually have a negative number. So this would be 5x minus 60 with a negative out front. So if you're still a little bit confused about this, what this is saying, if we plugged in 0, or if we plugged in 12 right here, so it would be 5 times 12 minus 60. We get 60 minus 60, which is just equal to 0. So if we got 0 right here, it would still be the absolute value. But if we plugged something less than 12 in, so say for instance we plugged in 10, we'd have negative out front, and we would have 5 times 10 minus 60. We would have 50 minus 60, and that equals negative 10. But if you remember, we have absolute value here, and the absolute value always has to be positive. But then because we have this negative right here, this negative and this negative cancel out, so then we still get positive 10. And so now coming back to here, we're looking at the limit as x approaches 12 from the left, to be specific. So if we're looking at it from the left, if we just have a graph here, and say okay, here's 12, here's negative 12, there's 0, here's 24. Since we're looking at it from the left only, we only care about this over. We don't care about what's actually happening at 12. We just want to know what's happening as we approach 12, just from this side alone. So since we're looking at it from this side alone, this is all less than 12. So we're going to be taking a look at this part right here. So since we're only looking at this part right here, we can actually rewrite this using this. So we would have the limit as x approaches 12 from the left of negative 5x minus 60 over 12 minus x. Now from here it just requires a little bit of algebra. So this we can just rewrite it in a different way. So if you took a look at the bottom, we could just rewrite this as negative x plus 12. Might be a little bit easier. So if we have this, we can just pull the negative 1 out. So we would have negative 1 times positive x minus 12. And then at the top, we can pull out a 5. So we would have, with this negative right here, we would have negative 5 times the quantity of x minus 12. Now if you're looking at this, you notice already this cancels with that, and we're left with the limit as x approaches 12 from the left, and then right here we have negative 5 over negative 1. That's 5, and we just have the limit of a constant number, constant which is a number, and that's just going to equal 5.